My dear students, so far in this lecture series on computer integrated manufacturing, we have discussed several topics related to computer integrated manufacturing or SIM. Those topics are prerequisites to know what is the computer integrated manufacturing, how we can achieve a computer integrated manufacturing system. As a part of that only, we discussed what is called as group technology, how to write part programs in CNC technology, and computer aided process planning, AGVs, ASRS, several topics we have discussed. They're all required as a systematic approach to achieve computer integrated manufacturing. This lecture I am going to discuss how to achieve computer integrated manufacturing, whether it is feasible. Can we apply the SIM technology to the contemporary with all the contemporary technologies that are existing in manufacturing for the existing plants in India and abroad as well? Whether this technology is it feasible and economical for a country like India, and let us all discuss that in this lecture. You can see that manufacturing is undergoing sea changes because it has started from the 1940 onwards. Manufacturing is always getting lot of changes. Whether it is introduction of CAD or the introduction of NC machine or robot, whatever it is, the basic functions of manufacturing are now augmented with computer. The computer is now controlling all the manufacturing functions. Like how the computer is invaded in every walk of life, it has influence on the manufacturing. Thereby, lot of changes have occurred in manufacturing and led to newer and newer technologies and competitive technologies. We are now in an age of competitive manufacturing where the product life cycle is very short and the order to delivery times are reducing day by day. So in order to survive in the market, you need to adopt the new technologies. Otherwise, there will not be a place for you to exist in the market. So one has to adopt the new technologies or computer aided technologies or computer aided engineering is used in manufacturing, in all the aspects of manufacturing. You see that in this slide, basically the computer, how the computer has been used to control the manufacturing functions. We have discussed the CAD/CAM technologies and FMS technologies and automatic storage and retrieval technologies, automatic inspection systems, automated assembly systems, industrial robots. They are all required and need to be controlled by a single computer, which is called as a supervisory computer. And from a single computer, let us again review whatever we have studied. Review that before we further go into the computer integrated manufacturing, achieving that. So Woodward's classification based on system of production, it has classified into three groups. The manufacturing systems have been classified into three groups: Group 1, Group 2, and Group 3. Group 3 is continuous process production. Group 2 is large batch and mass production, and Group 1 is small batch and unit production. The computer integrated manufacturing cannot be applied to Group 3. Similarly, Group 1 doesn't require to be implemented in Group 1 and Group 2. See, Woodward's classification of manufacturing systems falls into three categories: Group 1 and Group 2 and Group 3 kinds of things. Group 1, small batch and unit production systems comes under that. Group 2 covers all large and batch and mass production systems. Group 3, continuous process production systems. You know, the production of cement, production of chemicals, all of them falls under category of Group 3. To which kind of category we can apply the so-called computer integrated manufacturing technology? It is invariably, it is for Group 2. How we can apply? Let us see that. We know that the production systems, there are two levels to a production system. One is facilities, which consists of factory, equipment, persons, etc. And the other one is support system, manufacturing support systems, a set of procedures that are used to manage production and to solve the technical and logistic problems encountered in ordering of materials, moving the work through factory and ensuring the production meets quality demands, all the things. So production system, facilities plus support functions comprising of the production systems. Production system facilities to have the demands, how to meet the demands. You see the product quantity and product variety. A product variety, if is high, automatically for such kind of production system, the product quantity will be low. So this is low kind, high product variety system, which is falling under this extreme, this side of this graph, and comes to that side of the graph. In all discrete manufacturing systems, a production, a mass production. Okay, you see this popular graph, product variety versus product annual demand or production volume. This volume versus variety graph, you can see that we have a low, medium and high. Low in the sense the product variety is more, whereas volume is less, and this comes under the group 1 category of manufacturing systems. Similarly, group 2 and group 3 manufacturing systems. The job shop makes low quantity of specialized and customized product or products that are typically complex, one of a kind. So all job shops comes under the group 1 kind of industries, group 1 kind of manufacturing systems, or we call that as job shop industries, where product variety is very large and production volume is very small. Equipment in a job shop is generally a general purpose machines, and the labor force that are required in the job shop or skilled labor force are required. Plant is typically arranged in a fixed position or process layout. Typical layout is used as a process layout or a fixed position layout. We can see that those layouts are fixed production layout, that is a ship or a satellite or an aircraft manufacturing comes under fixed production layout system. And job shop, you can see this is a process layout where all same type of machines are kept in one place, like that in different places all the different machines are arranged, and this is also suitable for job shop kind of production systems. Medium quantity production systems are group 2 manufacturing systems. They are batch production. Product variety is very hard. Order of product are repeated and production rate of equipment exceed product demand. The same equipment is used to produce several different products. Changeover or setup time is lost production time or made to stock production. Cellular manufacturing product variety is soft. Groups of similar parts are made on same equipment arranged in cells, and group technology based system, manufacturing system can be adopted to meet the medium variety, medium volume production systems, that is group 2 and group 3 and group 2 it itself. Whereas we have mass production systems where quantity production, mass production of single part, huge in numbers on single pieces of equipment, use standard machines with special toolings. So all kinds of special manufacturing special purpose machines are used for this purpose, like Swiss screw machine or stamping press. There are all the different kinds of machines which can participate in mass production systems. Or flow line production, multiple workstations are arranged side by side in sequence or in a loop fashion, and parts or assemblies are moved through the sequence to complete the product. Uses production machines arranged in product layout, collection of machines as assembly line is designed specifically for one product to maximize the efficiency. This is, we call it as a flow line manufacturing. This comes under the mass production system only, because the production rate is very high and production variety is very low. That means it is limited to one or two kinds of parts only. World-class manufacturing system demands, today the world-class manufacturing is demanding that we require to have lower setup times. Setup times previously in conventional production systems, we used to have setup times in the order of 8 to 24 hours, whereas the demand is not more than 30 minutes. The today demand for the world-class manufacturing is 30 minutes only maximum time that is allowed. Can we do it? How to do it? We have to adopt new kind of technologies for that. Number of defects, previously we can afford to have 3 to 5 workpieces per 100 workpieces. If you produce 100 workpieces, we can afford to lose 3 to 5, which we call that as scrap. The scrap rate is now 3 parts to 7 parts in 10,000 components. If you produce 10,000 components, you can afford to lose 3 to 7 as scrap. That is 0.03 to 0.07 percentage. Cost of quality percentage gross sales. Cost of quality is 15 to 20%. To achieve the quality, we need to put some more amount. Okay, for that previously it is up to 20% extra. You can afford to have it. But today, only while doing the manufacturing itself, you need to achieve the quality. Only 3 to 5 is allowed for that. Inventory is, we can have some work in process inventory, maybe 3 to 4% of I. Here, no inventory, almost zero inventory. World class demand today is zero. You have to maintain zero inventories, because inventory itself is some item or is money which is laid out on the shop floor itself. So we cannot afford to have money in a stocking positions. So inventory is minimized in the world class manufacturing systems. Previously, distance moved by the parts within the shop floor is up to 5,000 feet. It is limited to 300 feet only, or less than 300. So you have to arrange, you have to plan your facilities such that the part can be moved at the most 300 feet only. Now let us see the house of manufacturing, because it is very, very, very important to know the psychology of the people who are working. Though you can automate, you can computerize the systems, but systems are being operated by human beings. As long as you do not change the psychology of the human beings, there are still some walls, invisible walls are existing between the two departments. That's what I'm going to emphasize, and why we require integration is this. Before that, one more thing, we can see that how the technologies are changing in manufacturing, or what kind of newer and newer technologies have come up in the recent past, so that how your SIM is modernized. See, previously in 1960, we thought of group technology, and 60 to 70 in production systems, applications of robots, applications of NC, and applications of some FMS and computer aided manufacturing. These kinds of things have come in between 1960 to 70s. In the 70s itself, direct numerical control concept previously developed has been implemented successfully. So we can control several sets of NC machines by means of one supervisory control, that is called as a DNC computer. Like that, and JIT concept also evolved in the Tokyo. A JIT has been evolved, and JIT has given minimum inventories and maximum output, maximum quality output, etc., etc. And it has given a lot of emphasis on that, and quality circle concept, everything has come up. So that is 1970, such kind of happenings. You can see this is that between 70 to 1980, in this decade, we have computer aided process planning systems, MRP systems, TPM, FMC, manufacturing control, small cells, flexible manufacturing cells, and optimum production technique. Goldratt, Goldratt has developed a technique which is called as OPT technique, and a theory of constraints. All of those things have been developed during this period and have been implemented successfully in manufacturing systems to improve the quality and the quantity, etc. And during 80s to 90s, we have modern, ultra-modern, the MRP concept developed in between 60s, 70s have been changed to MRP2, Material Resource Planning 2, and computer-aided engineering, and total quality management, whatnot, all those things have come up. From 1990 to 2000, we have the manufacturing systems with the lean concepts. You have the manufacturing system with agile concept, agile manufacturing systems, or lean manufacturing systems, or virtual manufacturing systems. VM means virtual manufacturing systems. Several things have happened, have been emerged in the manufacturing system itself. So there are improvised versions of the previous one and giving you better quality, better standard, and high production rates again. So I told you that there are different departments existing in the enterprise. You can automate all those departments. The functions of each department, you can automate it by applying computers and other things. You can see that operational management analysis you can apply, and this is production. You can apply all the functions by means of some computers, computer programs, etc. And HR you can apply. But you see, there are invisible walls are existing wherever these systems are automatized individually but not been integrated. When there is no integration, again they work as independently. When the sharing of information comes into picture, when this department and this next department to share some of the information, and that information is not changed, is not shared. If the information is not shared, the objectivity is lost. We cannot achieve the quicker retrievals, etc., and we cannot achieve the totally whatever the objective being proposed. You see, here's a typical example. Okay, it is to caricature kind of thing. You have the production, you have the design department. The design department, previously, design people used to design the component and used to throw it to the production people. Production people try to understand that and then develop the production planning and etc., and they try to measure that. Because there is lack of integration between the coordination between the design and manufacturing department. Design people can never thought of manufacturing functions while designing the part. So this is the scenario in up to 60s, 70s. This was the scenario even up to 80s also in India. In India, there are several firms. Okay, even this exists today. Okay, that means these design people, they feel that they are good, they are proficient, and they do the design. And manufacturing people say that such kind of tight tolerances or such kind of design changes cannot be accommodated on the existing facilities. So they throw the design back to the design people to modify the changes. These people modify and again throw it to them. So they don't share information. But suppose had the design people know what kind of facilities existing on that, what kind of closed tolerances are achieved, keeping all of them in mind, if they try to design, there will not be any throwings like this. Whatever the design people do it, they accept it immediately. So this is because of things being controlled by human beings, and human attitude is very difficult to control. Okay, what we did? We have removed many human beings in production. We have removed many human beings in the design department. Now design complete activity is automatized, and the manufacturing activity is also automatized, right? That and this are not sharing till now. Instead of human beings, robots are sharing the information. That's all. When sharing of information is not there, still, okay, we can't achieve the complete integration. A common database is generated. If that common database is shared by design as well as manufacturing people, we need not send back anything being developed by design department. So a common database is to be upgraded, which shall be shared for all manufacturing functions. By the all manufacturing functions, if the same database is shared, we call that as integration. So integration is highly necessary to avoid such kind of situations. So that's why we require CAD and CAM, and integration of CAD and CAM with CAP, okay, with other business functions will lead to a completely integrated environment, that what is required, or what is so called computer integrated manufacturing. So again, I would like to emphasize what is CAD and CAM and how we can differentiate CAD CAM with SIM. CAD CAM involves the use of computers to make design and manufacturing for more profitability. Parts of SIM use CAD CAM. CAD CAM is a part of computer integrated manufacturing, and products to try and make the factory fully connected using computers. So we need to achieve the complete integration. Integration is possible only through networking of computers, which are augmented for many manufacturing functions. Whether it is your sales data can be integrated with the design data. So your sales information is known to the design people, that is known to manufacturing people. So integration. Sales is a different function, design is a different function, manufacturing is a different function, inspection is a different function. All these functions of manufacturing need to be integrated in order to get the full benefit of the computer implementation in the manufacturing scenario. The essential difference is CAD CAM provides the tools, SIM is the philosophy which is used. When the organization, the computers, programs, etc., and all the information that flows between them. Another way is to think of SIM is that it allows the structure of an organization to be entered into computers. SIM focuses on connecting the various CAD CAM modules. See, we know that FMS is a flexible manufacturing system connecting various CNC machine tools connected by automatic material handling system, and they are all being controlled by a single shop floor computer. So SIM at factory level is FMS. SIM at factory level is FMS, right? So we have a factory is one function. There are other parts, there are other functions of that. FMS is not connected to that. Though people call FMS is connecting the design, is connecting the other sales and other HR functions, but it is not true. FMS is a SIM at shop floor level, right? Then what is SIM? The use of computers to streamline processes, make process faster, automate repetitive tasks, control processes, report generation on the various processes. Both production and administration wise, this implementation of SIM gives you the reports at different levels. For production people, it gives the report. It gives the report for the quality people. It gives the report for the administration at various supervisory levels. It gives the status reports generated at various levels. Right information is available to the right person at the right time if you implement the computer integrated manufacturing. Next. Now let us see the definition. There are a variety of definitions being proposed in the literature for the computer integrated manufacturing. That are, computer integrated manufacturing is a computerized integration of all aspects of design, material selection, planning, manufacturing, production, quality, assurance, management, and marketing. SIM, it expands the integration of CAD and CAM to encompass the administrative, engineering, and manufacturing disciplines in a manufacturing business. SIM integrates the factory of production to organize every event that occurs in a business enterprise, from receipt of a customer's order to delivery of the product. SIM is a unified network of computer systems controlled and are providing information to the functions of a manufacturing business in an integrated way. Another definition is computer integrated manufacturing refers to the integration of information processing requirement for technical and operational tasks of an industrial enterprise. It is an enterprise level integration. SIM is typically, in a two word, I can say that It is an enterprise level integration company. So lot of definitions. SIM is a philosophy rather than a specific system or a set of applications. By Lung, 1988, he has proposed this. You see this diagram. This is SIM jigsaw. We say that the integration is like this. It's like a network of functions. It has been put like that. No squares, not squares are joining. It is like a combed fashion. It has been integrated to this. Like manufacturing and CAM, SCAD, other computing, your company activities, all of them are put together, integrated in a high, like a what we call like a network, okay, like a netted one. If we integrate, we achieve complete integration, and the so-called computer integrated manufacturing is achievable. People, everything is integrated. Let us now discuss the typical elements of a SIM system. Manufacturing planning and control. We know it is a one function that is being now done by various softwares, various modules that are available to us today. One is MRP2, manufacturing resource planning or material resource planning previously, or CRP or shop floor control packages. All of them will be able to achieve the so-called manufacturing planning and control operations. Coming to the manufacturing engineering, that means you can say this CAD CAM, your design, generation of process plans, your planning people will do the planning. So now if you apply CAP package, the CAP is automatically done. Generation of computer aided process planning, process planning sheets and scheduling sheets, all the things will be automatically generated. This is manufacturing engineering function. We know we have computerized those things, and they are already available to us, like CAD, CAM, CAP, etc., and group technology, etc. And manufacturing process, that means your CNC programs, your DNC programs, your robot programs, your robot assembly programs, they are all required on the shop floor. If you have CNC machine, CNC program generation is required. All of them are now achievable. They are already, we have the CAD, CAM packages, DNC packages, FMS control packages. Today we have available, those packages are available, and they all meet the manufacturing process automation. Next, indirect functions. There are several indirect functions like sales, ordering information, finance, accountancy, budgetary planning, okay, and HR planning. All these are indirect functions that support the main functions of the manufacturing. So there also today we have payroll packages. We have HR personnel allocation packages. We have sales ordering process packages. Today you are all learning. We are all learning so-called SAP, so-called Marshall. These packages are giving a way to from this sales to the material functions, etc. They are all part of this only, but none of them are integrating all these activities. So we need to have, to integrate these functions like manufacturing planning, that means the supportive, these computer control packages, and all of them are, if they are all they are connected or integrated, we achieve the same system. Now just let us refresh our mind with the CAD technology and other things. I will be quickly glancing through these technologies. CAD refers to the use of computers to interactively design products and prepare engineering documentation. Extension is CAD is extended to design and manufacturing, design for assembly, design for manufacturing and assembly, like that. Design for manufacturing assembly enables testing of design integration before manufacturing. 3D object modeling enables us to the building of small models of the product before we manufacture. CAD CAM allows the transfer of information from the design stage into the stage of planning for the manufacturing of a product without the need of re-entering the data on or part geometry manually. CAD database is processed further by CAM into data and instructions for operating and controlling production machinery, material handling equipment, automated testing and inspection for quality control. CAM is capable of machining operations such as describing tool path for various operations. CAD/CAM applications, you can see that programming for NC, CNC and industrial robots, design of tools and EDM electrodes, quality control and inspection functions. CAM, capable of moving different parts of the machine in programmed coordinated environment. You can say CNC machines can be used to do this. The power supply system, hydraulics, electricity, pneumatics can be used in these devices. Actuation devices are such as stepping motors, AC, DC, hydraulic devices, they are all actuating mechanisms. And feedback devices such as encoders, Hall effect sensors, etc. And computer control unit, this part consists of a CNC machine control unit and the machine control software. SIM, integration of the production processes or production control and control of the firm. Also the product planning, design, manufacture and manufacturing plant and production system and communication between these applications. See, networking is the backbone of SIM. Networking is the backbone of SIM. So, what is that? Integration of the production processes. It is composed of information structure, enables every person in the company at whatever level to benefit for real-time direct access to all the technical and economical data needed for their work. Okay, this is very important function of integration. Production and inventory control, if you take, it manages the manpower and material resources of an industrial company to produce the best compromise between the three contradictory objectives: commercial, financial, production related. You see here is this simple diagram which is taken from U. Rumbold, Computer Integrated by Rumbold textbook. In this, here it is the CAD workstation and the data is stored here in the server, which is taken by the production planning control people. The database is used to produce CNC plot programs, CNC machines, and these two are machine tools for which the production control people will process and get the part programs, and they also take to generate cap and production schedules, etc. So this is all that can be done online. See here again the same thing, only this is the completely a shop floor control. This is entirely a shop floor comprising of several CNC machines connected by AGVs, and they have the controllers, respective controllers, cell controls are there. They are the controllers, and these controllers will be combinedly controlled at another station which is called as shop floor controller. One controller which is controlling all these individual control machines, and they themselves are connected to planning and design departments, and a distributed channel of networking is available to share the information and pass on the information. It's a two-way communication. Any information is shared, that information is used for a typical application, and then after that again the information is stored in the central database, and that can be further used by any of these at any level. A SIM system is made up of interface and network of computers. The general structure is hierarchical structure is just like this. It is a plant level and plant floor level and process level. Individual processes are being controlled, and the plant floor level they are being controlled, and individually at different plant layouts. Suppose we can have different plants also at geographically at distributed locations. We can have it, and all of them can be controlled by a single computer. Okay, like Reliance Fresh shops, the rates at Reliance Fresh different shops are being controlled by a single command control. From that rates, every time the rates changing are available to them. It's all only through network of computers, right? And online control, everything is online control. They have implemented only for sales information. In the Reliance Fresh shop, what you get is the information exchange is only for with respect to the sales, is it not? So the central database of an itemized, a barcoded item, number against which the present rate is available, and that will be monitored by central people, and those time and again how much discount is to be offered, how much other schemes are to be offered, they will decide, and online this is available to our shops here. Okay, at 10 o'clock if you purchase one kilo of something, could be different at evening 7 o'clock if you again go and purchase the same thing, the rate could be different. The rate is central controlled. So like that, they have channelized for sales network only, but in integrated manufacturing environment, all the functions are controlled. At process control, plant control, and plant floor control, plant control, and corporate level control. Okay, so that is what is this, and all these things have been explained here. Like a plant computer tend to drive the orders in the plant, in the factory. The plant floor computers focus on departmental control, in particular synchronization of processes, downloading of data, programs for process control, analysis of the results like inspection reports and other things. And process control computers are local machine control units, machines to control the specifics of the individual processes. Some of their attributes are program storage, sensory control, actuator control, process modeling, etc. So this is how the hierarchical level of the networking can be done. Next, please, to achieve SIM. This is also same thing. Now you see this. These are the important components of SIM. We have been telling here that what comprising of SIM? SIM is comprising of controlling of important things is manufacturing, process planning, product design, system management. Let us say product design comprising of these things already: computer aided design, computer aided engineering, group technology, DFM, and all other drawing standards, product exchange standards, BDES, IGES. Okay, they are all standards for exchange of information. Process planning, you have CAD/CAM packages, CAP packages, cellular manufacturing concepts, MAP, top technologies, step technologies. We have step technology, right? All of them are available here. And comes to manufacturing, NC, CNC, DNC, FMS, robots, AGVs, ASRS, automated inspections, cells and centers. And comes to systems management, we have PQM, we have EDA, MRP, JIT, Kanban systems, LAN, top satellite technologies. They are all networking standards, networking technologies, and these are all JIT concepts, just-in-time concepts. Okay, MRP standards, material resource planning and material resource processing technologies, barcodes and total quality management things. So these are all comprising of SIM. If all of them are connected by computers, and they're interconnected and share information, we achieve the so-called total enterprise is integrated. Okay, if a total enterprise is integrated, everything is recorded, every small minute change you do is recorded and share that information at every level, and resulting into the total control or computer. Same thing, another graph only, same one only in a modified diagram. This is called as SIM cycle or computerized elements of CAM system. This is also same thing, a shop floor level, and planning and design level, and top management. Okay, levels here maintains, and it is also sharing of information, networking of this information to achieve total integrity. Next, SIM, more than just automation. It's not an automation. SIM is not an automation, right? Remember that. It is only integration of all the information resources, right? Integration of the functions that are achievable on the shop floor and all other functions, manufacturing support functions. Shop floor automation or work cell control, we call them as islands of automation. That is automated. This is automated. This is automated. Manufacturing automations, another island. And information system integration, information shared across functional boundaries. I told you, we can remove the invisible walls only by sharing of information. Only by sharing of information. That is only shared by networking of that computer and this computer. If a network, information is shared. Design information is shared to manufacturing information. If you connect the design computer and manufacturing computer, okay, computer available on the manufacturing side and this is available. If I use the same design data here, and the same data I can use to generate part programs, to generate process plans, to generate that. So not necessary to take it from them and again re-entry their data here. Not necessary. So this is called as integration between CAD and CAM. And suppose if the levels of integration is been beyond the after the enterprise, what? After the enterprise is only customer. Is not. Enterprise is only interacting with the customer. Customer comes and gives the order and takes back the order. Is it not? Delivery is given to the customer. He will pay back the money and take the goods with him and go. And what? Suppose you wanted to enhance it further. Can you make SIM global? Right? How we can? You have to do the other functions also, like at the distributor level. After sales, what is there after sales? Is distributor is there. From distributor to the retailer, we have the sales functions are there. If all of them are also computerized and controlled with the shop floor, SIM is not only limited, it is go beyond that. So that is supply chain level also it can enter. It can enter into a zone where supply chain also be integrated with the existing SIM structure. Right? That is the next level of thinking only. So let us now just discuss the computer integrated manufacturing from the customer to the delivery, how it happens. Customer comes, places an order, okay, by computer, right? By email, you can place an order. Right? Today, by email, you can place an order on somebody. The order is received by the company business information system. Company business information system receives the order, which relays it to the local factory system. Okay? I got the order, right? I will deliver it to the local manufacturer. I have various varieties of enterprises. I can deliver it to this local fellow, right? And that at the factory order is scheduled for production. When the order comes, it is scheduled for production. Other planning starts, and the computer system sends the instructions to. You see, it shares this information with this factory machines, telling them what to do, and the shop floor activity what to do. Shipping department telling it to when to expect a product and where to ship it. So it also tells the shipping department when the order is going to be and where to ship it. That order information is also delivery information will be given to them. When the order is shipped, the information is sent back to the automatically for accounting purpose. The procurement departments, it also shares the information to the procurement department, what kind of necessary tools, materials and other auxiliary equipment that are required to produce this part are necessary, that will be purchased. Based on this information, it will be purchased or taken from the inventory, that will be taken and all sent to the shop floor for manufacturing. There should not be any delay. This information is shared so that there will not be any delay. So by the time some processing is done and all other equipment is available to do the total assembly. The assembly is done and it is tested, and then outside supplier is geared up for their own production and delivery to be able to supply parts just in time. This is sometimes some of the things you won't manufacture on your shop floor. So you need to give it to subcontracted items are there. So you will tell the supplier to supply those components to you. So this based on this information, all these things are alerted simultaneously. Okay, and as a result of that, you will be able to produce the part and supply it ship it to the customer in the right time. All corporate departments watch each phase. Corporate department watches each phase, how the things are going on. Okay, what is leftover time, and they monitor the entire all the things. Among them, accounting is done, which processes the billing once the product is shipped. So your bill is also ready. product and bill is sent to the customer, right? This is how SIM integrates all the functions of manufacturing. SIM integrates information flows in marketing, design, manufacturing, engineering, the resource requirement, planning, purchasing, production processes, quality assurance, administration into a closed loop control system. This is the total SIM. Same thing, whatever I told you have been given in this diagram. You see, each is a function. All of them are controlled. Each box itself is a function. Here, this is one is the shop floor. All these are all required for the shop floor to produce a component. Your design information is required. Testing is required. Outsourced components are required for the shop floor only. And shop floor only will be able to deliver and ship it to the customer. Next, please. Now, very important thing is that SIM couplings. In fact, I gave a talk on SIM couplings in 2003 in Seoul. I was invited by APO to present the country paper on computer integrated manufacturing. For that, at that time, I talked about only SIM couplings. What is the SIM coupling? You see this. You know that computer aided manufacturing activities are now controlled by computer. Is it not? We call them as computer aided manufacturing. Your CNC machine programming or DNC programming, your robot programming, they all comes under computer aided manufacturing. Computer aided design, computer aided planning, computer aided quality control, production planning and control operations, your scheduling, etc., etc. They're all important phases, important elements on the or functions of this manufacturing. You know, this is computer, this is computer, this is computer. Suppose if I have in my factory, I have CAD system, I have CAM system, and these two are integrated, I am using that. So this is one coupling. CAD and CAM is joined together is one coupling. CAD and CAP is one coupling. CAP and PPC is one coupling. PPC, CAQ is one coupling. Total integrated, all couplings. Everything is integrated with everything. All. So, in SIM, if you wanted to achieve the computer integrated manufacturing 100%, I have to have all couplings. That means all these areas are totally integrated. Or they are supposed to be integrated totally. But do we have that existing? Can we have it? Can we afford to have it? If you think and when in calculate with respect to money that you are putting in and the money that you are going to get it, if you think of that, I may say yes, I may say no also, because all the things are not required for all enterprises or all the factories. If you have a typical factory which requires more design, your design functions are more and less planning and other functions, and only limited manufacturing is there. So I may achieve CAD and CAM integration. If I incorporate the CAD and CAM facilities on that shop floor, that is sufficient to achieve. So SIM is achieved only 30% of that. I can say existing two couplings is 30% or 20% of achieving SIM itself, right? So this is what is called as coupling. Next. You see here, this is the coordination and organization of the data related to technical, manufacturing, marketing, financial, personal, planning. These are all the data that is you can top-down approach. You can see under quality what are the functions, and the information related to that is passed on to this, and we can totally the company can have the complete information. This information is available only if individual functions are computerized and all of them are connected. And I can share that as a computer managing director or CEO, you'll be able to know everything. He will not press the bell and call the person and please bring the file. I wanted to know how many people are working, how many are present, how many are absent today. He will have on his table, if you say that present day, who are all present and absent, automatically that information is available. Whoever comes in, the worker comes in, he will swipe his smart card and his attendance is recorded with all in-out times. So this is also related to that only. I'm trying to tell. Do we require any programming in the computer integrated manufacturing? Yes. Why not? There are a lot of programming languages which have been used by a variety of authors proposing literature on the SIM, and this is not limited. Any other thing which is presently existing, all of them are used as languages in the development of the computer integrated manufacturing. Plant operations, various operations, processing, assembly, material handling system, inspection, control, they are all being. I told you that coupling is there. How much integration is there in SIM? The integration is there in SIM. If all these areas, I told you, these areas, all of them are existing in your shop floor, in your factory, you can say this, your SIM is 100% existing. But a survey is made for all the European industries up to 2000 I think. And they made how many kind of couplings are existing in what kind of percentage. They say that one coupling is for 20.9% of industries. One coupling is existing. One means CAD and CAM, something like that. Two couplings, CAD, CAM and CAP kind of thing is two couplings are existing for this much of. Like this, 9 couplings are existing for 0.9 and 10 couplings are existing for 5.2. So we can say that 2-3 couplings are existing for majority of the industries. 1-2-3 couplings are. There are certain industries which doesn't have couplings at all. That means individual operations are being done. So that is, but other things are also available. That is, again, in this itself, how many forms are given? PPC and CAD, about this much of percentage of the things are getting. PPC CAD, 46.9% of the firms are using. PPC CAM, 46.9% of that. And CAD CAM, 45.2% of the industries are using. CAD and CAQ, 13.9%. Like that, if you observe this, more we can find is CAD CAM and CAP and PPC, CAP and CAD. This 1, 2, 3, 4, these couplings are popular couplings. Based upon the industry only, they use this. Okay? For their necessity, they use this. Right? And we can say that 100% SIM is not existing, but part of SIM is existing in those factories. Because some coupling is existing. Some CAD CAM integration is there, or CAD CAQ integration is there. Again, that same information is also being here. This indicates full integration. This color indicates little integration. So these areas are fully integrated and less integrated with respect to the various firms in that survey only. This is all based on an European industry survey up to 2000 this was done. So after that we can say that whether what kind of advantages of the computer integrated manufacturing we can achieve. That is responsiveness to the shorter product life cycles and changing market demands is very high if you implement SIM. Better process control emphasizes product variety and uniformity is another advantage. Support and coordinate exchanges of information between the application and the designing components for machining. Decrease the cost of production and maintenance through better use of material, machinery, personnel and reduction in WIP inventory. Save time and effort. These are the prime advantages of computer integrated manufacturing. Yeah. See, SIM wheel, people used to say this is the popular CIM wheel. Integrated architecture, information resource management and communications and common database. This is which integrates all your material processing, design, analysis and simulation and documentation. They are all scheduling, material management, material handling, shop floor. Okay, these are all again shop floor manufacturing control and factory automation, production process, and little bit beyond that, again your finance, manufacturing management, and marketing and strategic planning. They are all embedded. So you can start from here and to this, and this is encompassing all the areas to achieve complete integration as far as shop floor, as far as your enterprise is concerned. Next, please. So a lot of benefits, whatever we have seen, have been given percentage. Lowering of manufacturing cost. Lowering of, we can if we implement SIM, okay, the manufacturing cost could be reduced by 50%. Product quality can be increased up to 60%, and improved control, process control can be improved by up to 50%. And we have the various advantages of SIM with respect to quantified values have been given in this figure. We need some skill set in order to achieve SIM. Good understanding of the process is required. Ability to describe and define different computer integrated models is required. Ability to develop different solutions for same problem, they are also required. This skill set is required. Now I am asking a now philosophical question: do we need SIM? Because shorter run lengths and production time gets shorter. Part of startup in total production time gets bigger. Saving time is the key. Faster machines are no solutions. Same data at different places in different formats is available. There are things which are in hand. Now tell us whether we require SIM or not. Do we require SIM or not? Do we need SIM? This is again a very big philosophical questions. Yes, we do need SIM. For a higher profitability and for a more efficient production system, we need to go for implementation of computer integrated manufacturing. Thereby, the knowledge required for this CAM is highly essential for the people like you, because you are the tomorrow T-cubes, the tomorrow tool. One robot has been named as T-cube robot, the tomorrow tool. The tomorrow tool, TTT. So T-cube is. So the tomorrow engineers, you are all the T square M, okay, T square E, tomorrow engineers, right? So you need to have this kind of knowledge, which is highly essential. And with this knowledge, you must have to have a judgment whether you implement the entire technology or a part of the technology to get the quick solutions for the benefit of that. So there is always a trade-off solution. You have to via media solution. You need to choose and implement. You need not go for 100% integration. You may go for certain levels of integration, so that total benefit would be more. Benefit to implementation ratio, if you see that, benefit would be more. Okay, for the same cost input, right? Now, I would like to discuss if we achieve complete computer integrated manufacturing, how it would be. With a small case study, I am going to explain. That would be the end of my talk. Okay, this is the case study. A typical case study, steps for representing him, CIM. Let us discuss the implementation of SIM or achieving SIM with respect to a small case study. A customer ordered a mower deck part on an old model tractor. For a old model tractor, he ordered a deck part. So dealer used online CAD part catalog to get the part geometry. Next step is dealer ordered 4 parts from the factory. He immediately orders for the 4 parts of that particular part to the factory. The information is received at the divisional office. This information from the dealer to the factory, he receives the divisional office information, this information, and pass it on. Next, it processed further, and an inventory system found parts unavailable. The factory inventory system, okay, made a search for the parts, availability of the parts, and it is found that the parts are unavailable, not available. So a message was forwarded to material planning system. Production planner reviewed part assembly, indicating assembly robot. These things are also done. Otherwise, previously human beings only will do that and prepares the barcode and fix it onto this thing and transferred to the shipping or warehouse. From warehouse, it is delivered to the customer in time. Once the component is available in the warehouse, it is immediately delivered to the customer with some kind of courier services, right? Today we have the 24 hours courier service anywhere to anywhere. FedEx is one example of that. So parts are ready to go. This is how a SIM is achieved. Any questions, please?
Sir, payback period of a SIM implemented plant would be very high. So then how would it justify the implementation of SIM?
The question here is what is the payback period if we implement CAM technology? Suppose if you purchase a robot for painting operation, because of robot used for painting operation, the output is more, return is also more. If such returns are more and able to return your investment, what you have invested for purchase of robot within 5 to 6 years of time, that's how we have to calculate the return on investment. Similarly, if we implement a computer integrated manufacturing system, if you are sure of your return on investment is within 6 to 7 years of time, then you can go for it. Otherwise, you have to have a thorough analysis for that, because the return on investment should be aimed for that only, to 5 to 6 years of time. If it is more, then you will be nervous. So try to plan to have it. Otherwise, you have to go for partly implementation of SIM, which you can yield it to that. That is much more successful story.
Sir, it has been a decade since SIM has been introduced into the market. Why do you think it hasn't been such a big hit like the other systems?
Regarding question number 2, it is a very philosophical question whether SIM is a successful story or not. SIM is not successful in India because in India we have not even automatized other functions of the manufacturing itself. Still, drawing is done manually and production planning is done manually, and this is done manually. So unless we have implement all sub-functions, we cannot implement the total integrated manufacturing environment. So SIM is not successful because of this, because the subsystems are not completely computerized. Once all the subsystems are computerized, yes, SIM is achievable. And certain industries have implemented SIM to the extent of their production. There are successful stories of 27 industries in US have implemented total computer integrated manufacturing successfully, and they have the success stories. Remaining parts, because of lack of computerization of all the functions, they are not successful. India, no SIM system is available in India, but many people call FMS systems as SIM systems. SIM at factory level is FMS. SIM at factory level is just FMS, not the enterprise level. That's all. Thank you.